Good afternoon, students. Today we are going to start our fourth unit in the fourth paper, which is in a microcontroller. So, in the first unit of the microcontroller paper, we studied the 8051 microcontroller, and in the second unit, we studied instruction set and what are the on-chip components which are there in the 8051. We studied in the second unit, and after that, we have seen some peripherals, how to use the some of the peripherals which are there in the microcontroller in a stepwise manner. We have seen that one means using the timers to delay the time generation, to generate the time delay, and using the counters, how to count the events which are occurring external to the microcontroller, how to write the programs using the timers as well, means generating the time delay as well as to count the events, how to write the program step by step. We have seen that one in the second unit, as well as we've seen the serial communication, how to communicate with the peripheral devices which are dealing with the microcontroller using the serial communication. So we have written some programs to write the information, to read the information as well. In the third unit, we studied about some of the advanced microcontroller like PIC microcontrollers. In the PIC cases, we used to take the 16C, 6X and the 7X family as a basic one. So we studied the basic pin diagrams of PIC microcontroller like 16C, 61 and the 7 family. So some of the PIC microcontrollers are having the analog to digital converter, some of them are not having the analog to digital converters. We covered all those things in the third unit, means in the third unit of the first half of the third unit. In the second half of the third unit, we see in the PIC 16F877 family. So it is a flash microcontroller, means it is working with a little bit high speed compared to the 16C, 61 and 71 family. So some of the features which are not there in the 6171 family, they are integrated in the 16F877 family. We studied all those things. Now, in the fourth unit, we are going to study how to interface some of the peripherals which are missing in the microcontroller. Let us suppose I am going with the 8051. So if at all I would like to, what we would like to do is I would like to measure the analog information and display that information on the screen using the microcontroller. Obviously, we are supposed to convert the analog information into the digital format. So for that, we require the analog to digital converter, but which is not there in the 8051. So here we are going to study how to interface the analog to digital converter to the 8051 microcontroller, which is there in the PIC family, but it is not there in the 8051 family. And in the PIC family also, if at all the on-chip A to D converter is not sufficient, then obviously we are going with the external analog to digital converter to increase the speed or to increase the bit combinations. So all those things are there. Depending on our requirement, we are going to decide which analog to digital converter we are supposed to use. Okay. So in the fourth unit, what we are going to do is we are going to study about some of the peripherals like light emitting diodes, means how to in the interface the LEDs to the microcontroller, and push buttons, means in order to control the activities of certain devices, we are going to use the push buttons to give the connectivity and as well as to remove the connectivity. And we are going with the relays and latches. Relays are nothing but the main intention of the relays is to interface the high power supply devices, means when you would like to control the high power supply devices using the 8051 microcontroller or any embedded system. Embedded system devices are not working with the power supply with 230 volts and 50 hertz frequency supplies. They are not working with that much voltage. So like, let us suppose I would like to control the water pump in my home automatically, means it should be turn on and turn off automatically depending on the water level in the tank. So at that time, I am going to use the microcontroller basic system. In order to go with the advanced one, I am going with the microcontroller. Otherwise, we can go with the normal transistor also, but I am not going for that explanation in order to control the motor activities. I am just assuming that microcontroller is used in that particular setup. So when we are dealing with the high power supplies, our microcontroller kit is working with the simple DC voltage, not with the high AC circuits, AC power supplies. So at that time, we are going to use the relays as a bridge or the mediator between the AC power supply devices and the DC power supply device like our microcontroller. There we are using the relays, and we are having the latches concept also. We have seen the latches in in the third unit paper. In the third unit microprocessor case, we have seen the latches. We have seen means we studied the buffers as well as the latches in the third semester. We will review that one more time once we come across the latches. After that, keyboard, means in order to interface the matrix keyboard, the keyboard main intention is to give the instructions to the microcontroller or to give the numerical values or to enter the passwords, all those things. we are going to use the keyboard, and how to interface that particular matrix keyboard in the to the microcontroller that we are going to see in the keyboard concept. And 7-segment displays to display the information like decimal information on the screen. We are going to use the 7-segment display, and also we are going to interface the LCD to the microcontroller. LCD is nothing but liquid crystal diode. The main intention of this one is to display the information in the means to the user whatever the information you would like to print, like measured values are going to be displayed on the LCD display, or they may also be displayed on the 7-segment, but 7-segment is restricted to the decimal numbers. And LCD we can print the alphabets as well as the numerical values on the LCD. And after that we are going to study the ADC and the DAC interface into the 8965. So as I said, in the PIC microcontroller we are having the analog to digital and digital to analog converter, but in case of the 8051 microcontroller family, we don't have the facility of analog to digital, digital to analog converter as a on-chip peripherals. So that's why we are supposed to interface that one. So in the measurement applications, we are going to use the robot arm. The main intention of the robot arm is how the robot arm is going to be controlled by the microcontroller based on its position. So in the robot arm case, we are going to calculate the angle, how much angle you are supposed to move your arm from the reference position. So that we are going to study in the robot arm case. And after that, we are having the LVDT, which is a linear variable differential transducer. The main intention of this one is to measure the displacement values. To measure the displacement values, we are using the LVDTs, which is nothing but the linear variable differential transformer or the transducer. And after that, RPM meters, rotations per minute meter. So this one is especially used in the to indicate the speed of the vehicle. We may use this particular RPM meter. And after that, we are having a digital thermometer. So digital thermometer means to display the temperature value on the screen. We are going with the digital thermometer. So here LM35 we are going to study in the digital thermometer case, and we are having the strain gauge means in order to measure the strain experienced by a particular element, and that is going to be processed by the this particular microcontroller, and it is going to be takes the decision. Means if you want, you can interface the LVD strain gauge to measure the strain experienced by so and so thing and display that one on the screen. We are going to use the strain gauge as a transducer in a microcontroller case. And after that, we are having the controlling applications. Means when you would like to control certain activities automatically depending on its present activities. Activities in order to control the operation of this particular means a particular system automatically, we are going with the PID controllers. PID means proportional integral differential controller. So the proportional integral differential controller main intention is to improve the system activities with the error free. So to improve the system activities with the error free and increase the accuracy, we are going with the PID controllers. We are going with the PID controllers as a controlling element in the microcontroller based system that we are going to study in the PID controller space. After that, we are having the DC motors, means how to control the DC motor activities. Rotating the DC motors means increasing the speed of the DC motor and reducing the speed of the DC motor. How to control the how to stop the DC motor. All those things which we are going to study in the DC motors case. After that, we are having the stepper motor. So stepper motors are, as you know, the stepper motor is going to be rotates the rotor with a step angle, with a certain step angle, which you are going to decide and write that one in terms of the program, so that the microcontroller is going to be display rotates that particular stepper motor. So you may use the stepper motors case in robots. So in the robots you can use the stepper motor. DC motors are also going to be used in the robots, and in the instrumentation system we are going to study the servo mechanism, which we left in the third unit. So that servo mechanism is going to be plays a major role in that. Means the DC motors, DC or AC motors which are supporting the servo mechanism, those are called as the servo motors, and the servo motors are also be useful in the designing the robotics. So in designing the robots, so we are using those motors. Means we may use those motors in the at the neck part to rotate our head with a certain angle, or to rotate the head means completely 360 or to control the fingers of our robot, to raise the arm of our robot. All those things can be controlled by the microcontroller with the help of the stepper motor as well as the the servo motors. We'll see that one in the instrumentation case, no problem at all. So that is what we are having in brief about the fourth unit of our PIC microcontroller. That is the microcontroller paper, which is the paper 4. Okay. So let us start the first topic: how to interface the light emitting diodes to the microcontroller. How to interface the light emitting diodes to the microcontroller. Before studying about how to interface a particular component to the microcontroller, we should know what are the rules and regulations in interfacing the devices. We should know what are the rules and regulations in interfacing the device. Means if at all I would like to interface some external component to the microcontroller, is it possible to interface the external component directly to the microcontroller, or otherwise are we supposed to satisfy some conditions to the microcontroller is a question. What I mean to say that, let us suppose I would like to interface one device which is going to be supplies the pulses continuously to the microcontroller. Then is it possible to supply the pulses directly to the microcontroller or not is a question. So when you would like to interface something, or when you would like to send some information to one of the IC, whether it is a microcontroller or some other IC, let us suppose if you want, you can take the gates also. Gates also expecting certain amount of rules with respect to the power supplies. So if you are not satisfying those rules, even though you are observing that something is transferred to the microcontroller or the certain gate ICs, which are not going to be recognized by your respective ICs to which you would like to send the information, because it is not satisfying the conditions which you are supposed to supply, which you are supposed to satisfy. For example, I would like to let me take one simple AND gate operation. I would like to interface. I would like to send the high pulse and the low pulse, or AND gate means we are having the two inputs, right? Two inputs and one output. I would like to send the two signals as an input to the AND gate. So if you want to get the operation from the AND gate, you should satisfy certain condition. So whatever the AND gate ICs we are having, obviously they are working with the TTL family. So the TTL family devices are expecting the input power supply with the 20 milliwatts and output power supply is around the 25 milliwatts. Whatever the information which you are sending to the IC, if it is not satisfying this power supply condition, this power supply requirement, definitely your IC is not going to recognize your signal, and that is not going to be displayed on the screen. I'm sure about that one. So when you are doing in a lab case, you may say that, sir, whatever the logic inputs we are giving to the gates, they are working properly and finally showing the output. But it is wrong, because they are working. I'm not saying that they are not working. They are working without your knowledge. So actually we are providing the required amount of power. That's why they are able to show the information on the they are able to show the output from the gates. Otherwise it is not possible. Okay, now you have observed or not, I don't know, some of the ICs are getting heated when you are installing on that particular breadboard and turning on your power supply, and after some period of time, immediately you are going to smell some something bad smell, which you are going to sense, which is nothing but a burning smell you are going to come across. If at all the power supply is more, which is applied to the IC. So means without your knowledge, you are supplying the information in the required amount of power. Let us suppose if I am using one condition in such a way that if you are using the multimeter, then you can observe that it is a 5 volts only, but you are not going to get the output. I can do that one because I am going to reduce the current supply along with the voltage. Means when I am controlling the current, obviously the power supply applied to the corresponding gate is going to be less. So if you are expecting the 20 milliwatts, if I am reducing the current in such a way that which is not giving the 20 milliwatts and which is giving the less than the 20 milliwatts, let us suppose I am assuming that it is giving the 12 milliwatts, then definitely your information is not going to be recognized by the IC. If you are using the multimeter, generally you are going to check the voltage only, not the current. Okay, but you think that I am applying the required amount of signal, that is a plus 5 volts, but I am not getting the output. It is just because of the power supply. So that's why when you are trying to interface some external peripherals to the microcontroller, it's not that much easy what you are expecting. You are supposed to check it out what are the conditions and what are the what is the power specifications which we are supposed to satisfy in order to send the information to the microcontroller. So when you are taking the microcontroller, or when you are taking any IC or any device, first there is a rule for there is a rule for input operation as well as the output operation. So when you are supplying the information to the microcontroller, that one is called as a sink. When you are supplying the information, means if the microcontroller is accepting the information, that one is called as a sink. When you are applying the when you are applying the information to the microcontroller, is called as a sink, and when you are sending the information from the microcontroller to the other devices, is called as a source. One is a sink point, another one is a source point. Source point is different and the sink point is different. Sink point is called as a input device which is accepting the information. Source point is nothing but which is the output device, means a point which is able to send the information, or a point which is able to generate the energy to the external world. That point is called as a source. A point which is able to generate the energy to the external world is called as a source point. A point which is absorbing the energy from the external points, external sources, is called as a sink. One is the source point, another one is a sink point. So the same terminology which I am going, to apply to the ICs also. If the IC is accepting the information, means it is receiving the information from the external peripherals, then that particular IC pin is called as a sink one. So if at all that particular IC, one of the pin, is sending the information to the next level device, then that pin is called as a source point. One is a sink point, another one is a source point. So when certain pin is acting as a source point, it is going to be give some power conditions, power characteristics. It may be that purely depends on the IC, what type of IC you are using. So it may be the 20 milliwatts. So when you are giving the power supply, when it is acting as a source, it may give the 20 or 25 milliwatts. It may giving the 20 or 25 milliwatts. Wait a minute. I'm sorry. Okay. So when one of the IC is acting as a, when one of the IC pin is acting as a source, then it is giving some power supply to the, means it is sending the information with a certain power requirement. And when it is acting as a sink, it is receiving the information with some power requirement. For example, I would like to send the information from the IC to the external world. That point is called as a source, means the pin is trying to send the information to the peripheral which is interfaced to that particular IC. So at that time, it is able to send the information with a power supply of 20 milliwatts. With a power supply of 20 milliwatts. Remember, this numerical value is not going to be fixed. From IC to IC, it is going to be changed. So this numerical value is not fixed. The source, when a pin is acting as a source, means it is generating the signal, it is sending the information. So that characteristic numerical value which we are seeing, the power value, it is not the constant throughout the ICs. From the IC to IC, device to device, it is changing. So as per this case, in this PIC microcontroller case, it is when one of the pin is acting as a source, it is sending the information with a power supply of 20 milliwatts. When it is acting as a sink, one is a source point, another one is a sink. Sink means expecting the information, receiving the information from the peripherals. So that point is called as a sink. Okay, that point is called as a sink. So at that time, it is expecting the information with a power of 25 milliwatts. With a power of 25 milliwatts. If at all, whatever the IC which you are interfacing the microcontroller, if that particular IC is not satisfying this power information characteristics, means if you are sending some information, the IC is acting as a sink. So whatever the information you are sending, if it is not following with a power of 25 milliwatts, then definitely it is not going to be recognized by your IC. If at all the source is sending the information to the another device, means microcontroller is sending the information to the another device. If at all the other device is expecting 30 milliwatts of power supply, but when the IC of the when the pin of the PIC microcontroller is supplying the 20 milliwatts of power supply as a source, if it is not satisfying, obviously the whatever the device you would like to interface, that device is expecting the 30 milliwatts, but the microcontroller is sending the 20 milliwatts. At that time, what you are supposed to do, in order to establish the proper communication, you are supposed to use the amplifier. Amplifier is nothing but we are going to use the what is that, buffers. So the buffers are going to be amplify the information. That information is going to be transferred to the IC properly. So when you would like to interface one IC with the another IC, there is a power requirement. If this power characteristics are not satisfying based on the IC expectation, then definitely, even though you are sending the information in terms of the voltage, means you are assuming that I'm sending the 5 volts of power supply as a 5 volts as a binary 1, 0 volts as a binary 0, and why I'm not getting the outputs and why the IC is not responding, means these power characteristics. Whenever the power requirements are not satisfied, obviously, even though you are measuring the voltage as a 5 volts, then your information is not going to be transferred to the next level. So that is the main concept when you are going for interfacing the ICs. You should learn what are the source and sink what power characteristics in one IC and what is the source and sink power characteristics in the other IC. If both are satisfying, then directly you can interface. If anything is mismatching, then definitely you are supposed to do certain required elements. So you are supposed to use the intermediate elements to satisfy that particular condition. What we are expecting with respect to the ICs. Okay. So let us go for the first topic, which is nothing but interfacing the light emitting diodes. Interfacing the light emitting diodes. Interfacing the light emitting diodes. Okay, so we are having the unit 4, interfacing the peripherals to the microcontroller. So obviously in this case we are going to study about the push buttons, keyboards, latches, 7-segment display. External program memory and the data memory is not available. It is not belongs to our syllabus. So it is included. Analog to digital converter and digital to analog converter. So here the thing is how to interface the what is that, LED, right? We'll go with the LED first. No. I'll go with the push button first. Push button first. Okay. So how to interface the push button? What is the main intention of the push button? To indicate that whether the push button is open or closed, we are going to interface the push button is a 2-terminal element. So that particular 2-terminal element, one of the terminal is connected to the microcontroller pin and another terminal is connected to the ground. In this case, what I would like to do is, whenever the push button is closed, then I am expecting that 8051 should display the information as a 0. Whenever the push button is open, then obviously the 8051 is going to be displayed the information as a 5 volts. When it is pressed, it is going to be the 0. When it is open, it is going to be the 5 volts. Now, when you would like to read the information, here we are interested to show the present status of the push button, whether it is open or closed. In order to send the present status to the microcontroller, obviously you should make one of the pin of the microcontroller as a input pin. So we know that when you would like to send the information to the microcontroller, at that time the pin should be configured as an input pin. When you are making the one of the when you would like to send the information from the microcontroller to the next level devices, then at that time the IC the pins should configure as a output pins. Okay, now input pins as well as the output pins. But all of us know that from the first unit as well as the in the third unit of the PIC microcontroller. In the first unit we studied about the 8051. In the third unit we studied about the PIC microcontrollers. So all of us know that upon power supply or upon reset, all the pins of the microcontroller are acting as a input pins. All the pins of the microcontroller are acting as a input pins. So if you want to send the information, you can directly send because it is already configured as an input. If you want to send the information from the microcontroller to the next thing, then you are supposed to configure the pins as an output pins. We know that in order to make one of the pin as the input pin, you should write the binary ones, which is nothing but the plus 5 volts. In order to make one of the pin as the output pin, you should write the binary 0 on those pin lines, so that those pins are going to be act as a output lines. One is the input line as well as the output line. But we know that the pins of the microcontrollers are categorized into the ports format. We are naming, they are grouped into 8-bit format and they are named as a ports. Port A, port B, port C, port D, port E in case of the flash microcontroller in the PIC. In case of the 8051, the ports are named as a port 0, port 1, port 2, port 3. Okay, now these are the things. Means a group of pins are named with some name. Okay, now it is named with some name. So we list bother about the names, all those things. But when you would like to interface the input device to the microcontroller, obviously you should configure those pins. as a input pins. In order to configure the one of the pin or a group of pins as an input pin in case of the microcontroller, you should write the binary one. In case of the when you would like to make one of the port or some of the pins as an output pin, you should write the binary 2. We have seen IO port programming in the 8051 microcontroller case, means how to control the ports pins, how to configure one of the port as an input port, how to configure one of the port as an output port, as well as in order to what we say input port, output port. We have written the program also for testing the programs for testing the ports in 8051. In the third semester, we are having the practice. We have seen those practice, right? You would have observed that one. Virtually using the Kill software, we have seen virtual case, how to test the ports, whether they are acting as input ports or an output port. So if you want to configure one of the port as an input port, you should write the binary 1. If you want to configure one of the port as an output port, you should write the binary 2. So in this case, what I would like to do is, I would like to read the present status of the push button. I would like to read the present status of the push button into the 8051 microcontroller or into the PIC16 F877 family. So I'm least bothered about which pin of my PIC or the 8051 I'm using. I'm only bothered about one of the pin is used. I need to configure that one as an input, because I would like to read the present status of the push button. I would like to read the present status of the push button. So obviously, when you are reading the present status of the push button, you need to configure the this particular pin as the input pin. So when you are configuring that one as the input pin, obviously you are sending the binary 1. So if you are reading this pin status as the binary 1 inside the microcontroller, then definitely this push button is not closed, because if at all this one is closed, there is a contact between this terminal and this terminal. So when there is a contact between these two terminals, obviously it is bypassed to the ground. So ground is nothing but the 0 volts. You are supposed to read this input status as a 0. If you are not reading this input status as a 0, obviously this input is this push button. Means if you are not reading this one as a 0 and if you are reading this one as a 1, obviously this one is in the open. So if you are reading this one as a 0, then obviously it is in the closed position. So this is a simple format of interfacing the push buttons.